At the top of this where it says factoring expressions number 3, can you do me a favor? Please write factoring by grouping. Factoring by grouping. The first lesson you did was factoring binomial expressions. Then yesterday was factoring the sum or difference of cubes, and today is factoring by grouping. Okay, so to do this, the first thing we're going to do is we're going to look at these terms. And I can see that they're in order from the largest exponent on a variable all the way down to having no exponent. So I'm going to put a line underneath the first two. And then I'm going to ask myself, what's the largest group that I can factor out of both? So I can't factor a 5 out of both, but I can see that I can take at most 2 x's out. So I put an x squared out front. And I'm just going to do this for it. It'll be easier for me to write on 1 second. And after the x squared is out front, I put a parentheses behind it. X squared times what quantity is 5x cubed? I need to attach a 5 and 1x. Now, if I distributed that x squared, I'd end up with 5x cubed. X squared times what is negative x squared? The answer is negative 1. Now, here's the tricky part. Whatever is in parentheses, you're going to take that exact same amount, and we're going to rewrite it in back. 5x minus 1. In front, put a really light question mark. Now, over the top of that question mark, 8019. Over the top of that question mark, you need to determine what value, when you take it times 5x, do you end up with a positive 25x. Okay, and we have to say whatever number we say, it has to be a plus or minus in front. So we believe it is positive 5. Do you believe positive 5 times negative 1 is also negative 5? So put down a positive 5. Once again, if I distribute positive 5 times 5x, that works, and positive 5 times negative 1, that also works. If you can't determine a number, it's not factorable. Okay, here's the very last step. Both the front and the back contain the quantity of 5x minus 1. You write it down one time. What's in front of the parentheses 5x minus 1? X squared. In the back, what's in front of the parentheses 5x minus 1? Positive 5. Answer is complete. Example number 2. First I look, I can see that it's in order from the highest exponent on the variable down to having the lowest amount, which is x to the 0, or n to the 0 in this case. Okay, so it's already lined up for me. Again, this is n to the third, n squared, n to the first, n to the 0. Okay, great. So I'm going to look at the first two. What's the maximum that I can take out of both or factor out? Well, they're both even, so I can factor out a 2, and the most n's I can take out would be n squared. 2n squared. Well, 2 times 2 is 4. I need a total of 3 n's, and I only have 2, so I need to attach one more n on. All right, 2n squared times what quantity is a negative 2n squared? The answer is negative 1. Here and here. Okay, then I take whatever was in parentheses, and I rewrite it in back, and really lightly I'm going to put a question mark in front. What value times 2n is a positive 2n? And what type of 1? Plus or minus? Okay, I'm going to write it really light in case I'm wrong here. And is positive 1 times negative 1 negative 1? Yes. Okay, so this is factorable. Both the front and the back contain a 2n minus 1. In front of the first 2n minus 1 is a 2n squared. And in back, we can find a positive 1 in front of the 2n minus 1. This problem is complete. Just curious, thumbs up or thumbs down if you remember doing this. Okay? Please make sure all earbuds are out right now, even if you're not listening to anything. Okay? Next up, are they lined up? Yes. N cubed, n squared, n to the first. All right, so here we go. I can factor out a 4n squared. 4 times 3 is 12. I have 2 n's. I attach one more. Now I have 12n cubed. 4n squared times negative 1 is negative 4n. I'm going to copy and paste what was in parentheses. What value times 3n is a positive 9n? I believe it's positive 3. And it's positive 3 times negative 1, negative 3 it is. So this is factorable. They both contain a 3n minus 1. The front is 4n squared in front of the first, and in front of the back is a positive 3. This is just another way, it's like restructuring the terms. This is equivalent to our original expression. Number 4, we're half done. First, let's make sure everything is lined up. Okay, x cubed, x squared, x. Okay, great. And I'm going to factor out of the first 2 and x squared. X squared times 4x is 4x cubed. I have to attach an additional x on to raise it up to 3x's. X squared times negative 1 is negative x squared. Whatever's in parentheses is copied and pasted back. What quantity times 4x is 12x? The answer is 3. And it's 3 times negative 1, negative 3 it is. So this is factorable. They both contain a 4x minus 1. In front of the first is x squared. In front of the second is a positive 3. One more time, can you do a 1 through 5 year level of understanding before we raise up the level? Okay, we do have some 2s and some 1s, I'm assuming because you did not take Algebra 1, 2 on our campus. All right, here's your next one. Number 5 looks a little bit different. The first thing is, do you see how we have a 6, an 18, a 42, and a 56, how they're all even? If they're all even, they are also divisible by 2. So let's factor out a 2. Oh, I'm so sorry. Thank you, Stella. Could you see the other problems are done?
No.
The last problem nobody saw?
The last one.
Better? Do you guys need to write it down? Okay, so here we go. We have number 5. I'm going to divide each term by 2. And now within this, I'm looking at the first 2 terms. 3 and 4, I cannot factor out a numerical value, but I can see they both contain an m. So I'm going to bring an m out. M times 3n, when I distribute, would be 3mn. M times positive 4 is positive 4m. Whatever's in parentheses goes in back. What times 3n is 21n? The answer is positive 7. Is positive 7 times positive 4 28? It is, so this is factorable. What's in parentheses is 3n plus 4. What's in front of the first is m, what's in front of the second is 7, and bring the 2 down. Okay, example number 6, 3 left to go. Example number 6. These are all divisible by 3, so I'm going to start by factoring out a 3. It's like example number 5. 5n cubed subtract 10n squared plus 4n minus 8. In the first two terms, I'm able to factor out a 5n squared. Now, if I distribute that 5n squared, what would have to be inside the parentheses to end up with 5n cubed minus 10n squared? It would be 1n minus 2. Copy and paste the parentheses n minus 2 and back. And what value times n is a positive 4n? It would be a plus 4. And plus 4 times negative 2 is a negative 8. What's in parentheses? What's in front of the first parenthesis and then in front of the second parenthesis? If you forget the 3 up front, it would be wrong. we've restructured it. This is an equivalent expression to up above. Example number 7. Now this one, not only can I factor out a 3, they all can have an x in them. So I'm going to start by taking out, I'm going to take out a 3x. When I factor out the 3x, I'd be left with 2x cubed plus 1x squared, subtract 8x minus 4. The first two terms in the parentheses, they're all lined up. I can factor out an x squared, and I'm left with 2x plus 1. I'm going to copy and paste the 2x plus 1, and then determine what value times 2x is a negative 8x. The answer is negative 4, and negative 4 times 1 is negative 4. Now this is the problem that every group that I asked up to this point has given me a wrong answer initially. 2x plus 1 is in front, and then x squared minus 4, and don't forget about the 3x. What I've done is not wrong, but if I stopped here and assumed this was fully factored, it would be wrong. Vivian, what do you think I can do still? Sure, what do you think I can do still that I can take it one step further? That's a great guess. We want to keep it factored. We're going to come back to you. Ruben, what do you think? Brian? Angel? Angel G?
Would we not do what we did the first time?
Yep. So think of what you did Monday. Which one of these groups can I take it one step further? The last one. Is 1 and 4 both perfect squares? Okay, is this a divisible by 2? Is it even? And subtraction. This becomes 1x plus 2, 1x minus 2, and then bring everything else down. This would be the final answer. You don't need to have 3x in parentheses. This is your final factored form. Okay, our very last one is example number 8. So not only can I divide by a numerical value of 2, I can see they all contain at least one m I can pull out. So I'm going to factor out a 2m. Then in the first two terms in the parentheses, the most I can factor out would be the variable m. What value times 3n is 18n? A positive 18n, it would be 6. Let's make sure this is factorable. Okay, that works, and this also works. So they both contain the parentheses 3n plus 1. In front of the first parentheses is m, in front of the second is 6, and don't forget about the 2m out front.